Okay, a very good afternoon, everyone. My name is Zheng Leong. I'm the co-founder of Automata Network. So today I'll be kind of like talking about AI agents and like basically have a friendly chat on everything about AI agents. So what we have now really is this shift in this entire AI kind of like landscape and ecosystem. So previously, when we have like uh, models like neural networks where we can make prediction, make categorization predictions, and then we move on to large language models where we can interact with these models by providing like certain natural language prompts. And the next step from it really is a kind of like usage of all these large language models to kind of like operate or interact with certain tools or browsers or APIs that we have. So what we have is this kind of like evolution from one that is kind of like passive, where the user is actively or the user is actually instructing the model to do certain things, to one where the model actually attempts to make certain decisions and interactions by itself. So there's this kind of like shift from less autonomy to actually more autonomy. So really, what is the problem in it? Like, so what if there is this increase in autonomy in the kind of like AI tools or machine learning tools that we are using? It's because with the increase in autonomy, how this we are kind of like delegating a lot of the decision making to the models themselves, and with that, it becomes increasingly important for us to actually kind of like have a sense of how all these decisions are being made. So for example, if I ask the LLM or if I ask the AI agent to help me book a ticket to say Denver from Singapore, like my intention for the model is for it to like book the cheapest flight from Singapore to Denver, or like the most cost-effective flight from Singapore to Denver. But what is stopping the agent from actually, because of certain advertising collaborations of the company with some companies, book a ticket that doesn't kind of like align with what I expect? So this kinds of like act as an example on why we need to kind of like, there's this increased need for trust in the agents that is operating on our behalf. So with respect to that, like, what are some, if we kind of like break it down, specifically what are we looking at? What is this trust that we are talking about? Really, it's like three kind of like components to it. The first one is integrity. Like, is the AI model indeed what it is? Is the AI model what I expect it to be? For example, if I'm using, say, ChatGPT, if I'm paying $200 a month for ChatGPT o1, I want it to be o1 and not like ChatGPT 4.0, right? So the integrity of the model itself. Confidentiality is the data that I'm sharing with the model or the prompts that I'm giving the model kind of like constrained within this particular session that I'm with. There's no other third parties that can have access to my data without my explicit kind of like permission. And the third one is really like provenance, kind of like, there's this saying, rubbish in, rubbish out. So the thing is, I can have I can have the most perfect model in the whole world if the model doesn't have kind of like secure input. That means it's some malicious input that's given by some external party. Then there's no way the model can actually make the correct decision, because the decision that the model is basing it on is actually on unsound data or like incorrect data. So like these three kind of like form this triangle on agentic trust. So we kind of like move a little bit further on. Like, if a lot of times when you're interacting with AI agents, there's no sense of where this agent is. Like, what exactly is an AI agent? Most of us would interact with an AI agent or a LLM via like API that we purchase from, say, OpenAI or from Google or from Anthropic, so on and so forth. But really, if you think about it, there's this kind of like, this is where a little bit of like philosophy would creep in. Like there's this mind-body duality where if you think about it, we have the model that is like the mind, and we have the machine, that the actual hardware that this model, this AI agent is running on, and that forms like the body of this agent. And I think this would be very important if we are trying to establish like what this AI agentic trust would be. How would we actually verify if this AI agent is indeed what it is? I'll kind of like touch on it further on. So with that, right, like today, I'll be kind of like sharing a kind of thought framework that I have really on how can we kind of like categorize and layer out like the levels of the different levels of agentic trust, and how we can progress up the level to have a more trustworthy AI agent. So in kind of like in general, you can think of it as like 3 different steps. You have the kind of like least trustworthy and opaque AI agent, and then on the furthest end, the most trustworthy sense, we have an AI agent that's fully autonomous, that's completely aligned with what I intend the model to do. So let's take a look at the kind of like breakdown. So the first level is really like opaque AI agents. It's what we have now. Like we have a particular API key to OpenAI or Claude or say Google Gemini. Users actually have no way of verifying what agent is actually being run. We are actually required to trust the operators or the API providers that this is what they are providing us. In this kind of scenario, there's actually a possibility of backdoors. Like, I think one of the more common situations is like, for example, for OpenAI, how do I know that the model, that the response that I get from the API is indeed the specific model that I want? There have been some discussion on how, OpenAI is like shadow banning usage of their APIs by providing a lower grade model in terms of the response. Whether is it true or not, we absolutely have no idea, because we have to trust the providers blindly. So how can we actually do better? That's where level 2 comes into play, like verifiable AI agents. So like I mentioned, we can think of like AI agents, or in general like machine language models, as having this mind-body duality. That's the mind, that is the model itself, and the body, which is the machine. So what if we actually have a way to kind of like verify that it is indeed this mind that I'm talking to, or is indeed this model that I'm talking to? There are several techniques that we can kind of like utilize here. We can use things like TEEs, where we can have a verifiable execution environment that attests to the code that is actually, the code and data that is actually being executed within this environment. TEEs provide us with capabilities like code integrity, which kinds of like fallbacks to this is the specific model that I'm running, and data confidentiality, that the data that I'm providing the model is not leaked to any third party, and only the model itself has access to this data. Of course, we can also use other cryptographic primitives like ZKML or maybe ZK-MPC-ML to actually perform this assertion, this attestation. So that there's no like one way to do it. We can make use of any kind of like primitives that we have to achieve this verifiable AI agents. Then you might be thinking, yeah, now we have this verifiable gadget. We have this way to actually verify the agent. We are done, right? Actually, not so much, because what we have here is the ability to actually measure what is being executed. But how do we know that whatever that is being measured is actually what I want? So for example, there's a model that's running in a trusted execution environment, and a report is produced. There is a code with the following hash, OX ABCDE. How do I know that this OX ABCDE, this hash, actually correspond to, for example, ChatGPT 1.0 Pro without any backdoors that is involved in it. So we need to have a way to actually link the actual kind of like entity that we are interested in to the code that is actually being measured and executed on the machine. So this is where level 3 comes into play. How can we achieve it? We can have open weights that are like available for open source models like Llama, DeepSeek. We can have a testable builds. For example, I can have an environment where it would reproducibly compile and build the model and then make an attestation on it such that I can link this particular model to the hash that I see running within the enclave itself. Or if it's a totally closed source model, maybe a third-party auditor can be engaged to provide a kind of like professional attestation that this model is indeed does indeed correspond to this particular hash. So like all of these are possible ways on how we can draw the linkage, but we need to have a way to actually draw this linkage. And then if we can draw this linkage, we are able to kind of like prove the authenticity of this AI agent. Now at the fourth level, after we have kind of like proved that this agent is indeed who it is, you can kind of like think of it as I have this like secure call. I have this call where I know that my agent is what I think it is. No one can actually modify the agent while it's running. No one can peep into the agent and extract data from the agent. The next step really is that this kind of like this agent or this call is like isolated. You can think of it as our consciousness that is stuck in our body, right? We need to have ways where we interact with the outside world. We have eyes to actually look at our environment. We have ears to listen to sound. So how the decision that I make is as good as the information that I receive. At level 4, we want to be able to prove that this information that we receive is indeed trustworthy. So for example, if I have an AI agent that deals with meme coin trading or deals with certain on-chain trade that I would like to make, if that is what I want, then I need to ensure that the information that this AI agent has, the on-chain information, is indeed trustworthy. And it is something that happened on-chain and not some data that is injected into the agent by some malicious third party that is going to exploit my position, my trade position. So this would kind of like involve things like trusted data pipelines and data provenance to track the authenticity of it. For example, I might want to run a light client within my AI agent such that the AI agent itself can verify the external data. Or I can have a verifiable RPC where the RPC itself is running within a trusted execution environment, and then the AI agent and this verifiable RPC can do a mutual attestation to establish trust, and the data that is consumed from this RPC can then be considered trustworthy. Now, with kind of like, once we reach level 4, we have a pretty trustworthy system. We have an AI agent that we have verified the integrity of it. We have kind of like our outside sensors, like data that's coming into the AI agent and APIs that the AI agent is interacting with. What else is more, right? Like that should be the end. Actually, that's where the 5th level actually come in, like truly autonomous AI agent. This kind of like bring back, again, back to the philosophy that I'm talking about. If you are trying to verify an AI agent, what exactly is an AI agent, right? Like, is the AI agent the LLM model, or is the AI agent the LLM model plus the components? So for example, ELIZA OS, like there's the LLM model that makes the decision, and then there's all the plugins. So at which point in time is an AI agent a specific AI agent that I'm interacting with? So let's say if I have a machine that is running a particular instance of Gemini 2, is it considered the same AI agent if I change to another machine and run that same model on that machine. So it's just like, you know, the ship of Theseus. Like if I have a ship and I keep replacing each part of the ship, at what point does the ship stop being the ship itself? So with this, there's a kind of like need to actually establish like what exactly are we concerned about. So in our viewpoint, really, the kind of like AI agent really is the context, the memory, the identity of the agent that we are interacting with. So you can think of it with respect to the LLM as the kind of history, context of my interactions with the LLM. So that actually forms this identity of the agent that I'm interacting with. And I would need to be able to actually verify this history, this memory of the AI agent. And other than that, we also have things like, oh, how do we know that the model itself is actually making a right decision? How can we ensure the alignment of the model itself? This in of itself is actually an open research problem. There are a lot of ML researchers that are working in this area. For example, like how can we identify potential backdoors that's embedded in models? We can verify the model. We can identify that this is indeed, for example, ChatGPT 1.0. But how can we ensure that there's no backdoor in ChatGPT 1.0? So these are some of the questions and open research problems that we need to solve in order to address this. So with that kind of like out of the way, what I would like to share here is really like what Automata Network is doing as a first step to enable us to have this like trustworthy AI agents. So what we have now is we actually have this on-chain attestation explorer where we can kind of like, we allow people who want to run AI agents to run these agents within a TEE and submit the attestation reports on-chain. That would allow us to at least reach the level 2 of our agentic trust scale, or even up to level 3 if there's a way to link up the model. And this kind of like allow us to have transparency and accountability in the agents that we are actually running. And finally, it's a kind of like, we are a blockchain company. The blockchain is this public ledger, and it's a decentralized public ledger. We would want the AI agent itself to be closely aligned with kind of like public transparency and to inherit the kind of like decentralized trust that we have in such systems. So with respect to that, and to enable more people to kind of like make use of such, to more easily make use of such tools, we have actually written a decap plugin for ETHDenver. You can directly just use it, and it would actually submit an attestation report of your agent onto our rollup, basically. So in terms of the actual attestation itself, you can either the underlying plugin will use either Fala Networks DStack or the SGX plugin that is available for ETHDenver. So with that, that's the end of my presentation. You can find us online on, say, Twitter or our Discord. And that's it. Any questions? Yep.
My knowledge on TE is very limited, other than from a very high level, it's similar to a VM, and you run your program in there, and you're sure it's going to run in the way it does. I am assuming, and like I want to see if my understanding here is right. I run like DeepSeek R1 on a TE, and then it can create an attestation after it has generated the response to a prompt, and that's what goes on top.
Actually, it can be used this way, but how we would typically use it is that you would run a TE, you'll run this DeepSeek in it, DeepSeek R1 in it, and then there will be an attestation to a key that is embedded that only the TE knows. So you can think of it as I'm actually registering a key to the machine, and then this key will be used to sign off any messages that is sent by the machine. So
and
yes.
How do we know that this key hasn't been read by anybody else or whoever set up the TE?
So the TE itself will give guarantee on the code integrity and the data confidentiality of the enclave itself. So if, correct. So for example, I have a piece of code that I'm running inside the enclave that generates a key. So if there's no instruction, if there's no way in the code that exfiltrates this key, there's no way any external parties can know the key. Yeah. So you can think of it as if there's no API key for me to read the key, then I'm not able to extract the key out of the TE.
Cool. Thank you.
Thank you.